Y'all. So I'm going to do a quick video over cones, which is going to be tomorrow's Webex lesson. And again, we're keeping them straight and to the point. So let's go ahead and get started. I'll do questions tomorrow over any previous material that we've done. And then we'll dive right into cones. So we got our solid here, where cones are extremely related to cylinders for obvious reasons. We basically take a cylinder and take a machete to it and just start slicing it down into a cone. We still have a radius, we still have a height, but what is different now is we have a slant height. Unlike a cone, a right cone, where the height here would be the same as the side of the height, this is now called our slant height. It's been referred to at times as lateral height, but we're going to call it slant height. Okay? So let's go ahead and get going. Oh, and of course we have a vertex up here. So we're going to just basically plug and play formulas like we did on cylinders, and we're going to focus right here on, first of all, we'll do lateral and surface area of cones. So I want to compare the formulas real quick. Now let's take a look at cylinder and let's take a look at cone. Basically what's happened is the surface area of a cone is half that of a cylinder. So all we do is divide by 2. Pi RL. Now this H is the height. This L is my lateral height, so it's going to be this height right here. Okay? So it's going to be this length. So pi, and then R, and then times L gives me my lateral height. Now to find the total surface area, because all we're doing is just painting this top part here, we're going to have to add in the area of the base at the bottom. That's just simply one base of pi r squared. Whereas a cylinder would have 2 bases, the top and the bottom. The cone just has 1 bottom. Okay? Moving on. So again, plug and play formulas, but I want you to do this. Every single problem, I want you to write down your radius. I want you to write down your L, and I want you to write down your area of your big B as base. Okay? So your R radius is 6. Your L is right here. This is L, so that's 10. And area of the base is just pi r squared, okay, which is pi times 6 squared, which is equal to 36 pi. Once you do this, you're just plugging these numbers into your formulas. So lateral area is pi RL. Well, n goes to 6, n goes to 10. And that's it. So it's just pi times 6 times 10, which is equal to 60 pi. You can throw that in your handy dandy calculator and get 188. 188.5 is what it says on my calculator here. And that's unit squared. Okay? Unit squared. Your total surface area is this plus the area of the base. So you can still plug it all in if you want, but there's really no reason to. It's just going to be 60 pi plus, because I already did area of the base, 36 pi is equal to 96 pi, okay, which is about 301.5 units squared. All right? That's all we're doing. So this is critical to write down before you get started. You should do that on every single problem. So we want our R, we want our L, and we want our area of the base. Well, our R is missing, but this is just a squared plus b squared equals c squared. If you remember your Pythagorean Theorem, this is nothing more than 9. All right, your triples. So R is 9, L is given to us at 15, and big B is pi r squared, which is pi times 9 squared, which is equal to 81 pi. So 81 pi. All right. So lateral area is pi RL. Well, got the R and we got the L. So it's just pi times 9 times 15. Once we have that, we get 135 pi. Yay. Okay, so this is just 135 pi. And we're just going to add 81 pi to it. So surface area is just 135 pi plus 81 pi is equal to 216 pi, which is about 678.5 units squared. All right, let's see, I got one more example for you, and then we'll get into kind of a word problem. Oh no, this is volume. We're going to do volume now. Now, volume of a cone, if you take a look at your volume of your cylinder, it's just area of the base times height, which was nothing more than area of the base with pi r squared times height. Okay? If you look on other formula charts out there, you might even see that. Well, it turns out that a cone is exactly 1/3 the volume of its cylinder of equivalent dimensions, same radius and same height. So now our dimensions are going to be height and radius. So that's what we should focus on. So dimensions of height and radius. Well, we don't have height. We have lateral height. This is my lateral height. But we need our height right here. We have to form that right angle. This is not a right angle. So we got to do a squared plus b squared equals c squared. If you know your Pythagorean triple, that's a 3, 4, 5 triple. So that is 8. All right. So we have r is equal to 6. H is equal to 8. And area of the base, which is pi r squared, is equal to pi times 6 squared, which is 36 pi. All right? So you're going to do the same thing you did here. You're going to write down, only now you need your h instead of L. Plug it in. Volume is equal to 1/3 area of the base times height. 36 pi goes right here. 8 goes right there. 1/3 36 pi times 8. Well, that's just going to be 12 times 8. It's going to be 96 pi. Put that in the handy-dandy calculator if you want to get a decimal answer. And you don't have to on your homework if it doesn't specify. If it's not a word problem, I actually prefer exact. Units cubed. There's your answer. All right? But this unit cubes is actually good enough on your homework. Moving on. So we got our height, we got a slant height, but we don't have our radius. So guess what? Pythagorean again. A squared plus b squared equals c squared. Well, that's another triple. We do lots of triples here. So that's going to be 9. So r is equal to 9, height is equal to 12, and big B is equal to pi r squared is equal to 81 pi. Okay? 81 pi. So volume is equal to 1/3 area of the base times height. In goes 81 pi. In goes 12. So here we are. We're going to have 1/3 times 81 pi times 12 is equal to 324 pi. And again, you can leave your answers like that if you want, units cubed. Or you could just toss it in the calculator and do this. Okay, so sometimes we get a little bit more interesting. So what we have here is a volume of a cone with a height of 12 and an area, a volume of 144 pi. First thing you want to do is write down your formula. Volume is equal to 1/3 pi r squared, area of the base, times height. All right? So let's go ahead and solve for what we know. Put in what we know, not what we don't know. And solve for that. So we're going to have 144 pi. We know the volume. We know the 1/3. We know the pi. We don't know the r squared, but we do know the height of 12. 1/3 of 12 is 4. So we got 4 pi r squared. All right? So the first thing I'm going to do is I'm going to get rid of the pi's. We got them on both sides. All right? Then I'm going to divide by 4. Well, when I divide by 4, that gives me, let's see, did I do that right? 4? Yeah. So that's going to be, 4. How many times does 4 go into it? I had dropped my calculator. Help me out, some student. 144 divided by 4 is 36 pi. Okay, where are we at? Here we are, 36 pi. I should have known that. All right. Well, it's my cat's fault. You should see what he's doing right now. Okay, so r squared, oh, there was no pi, is equal to 36. R is equal to 6. Okay. Alrighty, and I think, I got one more for you. Okay, rotations. So rotations is when we're going to rotate across the y-axis, we basically reflect this across, connect, all right, draw a little circle here, all right, and there's our cone. And since we're finding volume, we need the radius, which is given as 3. We need the height, which is 2. And we need the area of the base. Well, area of the base is equal to pi r squared, all right? So that's going to be 3 squared is 9, so it's going to equal to 9 pi. Volume is equal to 1/3 pi r squared times height. So 9 pi, so I have 1/3 times 9 pi times 2. That's 3 times 2 is 6. All right? And that's going to be units cubed. You can put that in the calculator and get a decimal answer. Alrighty? So I'm going to go ahead and save this and get this posted to the internet. Yippee-yay.